Welcome to Math 15. We're going to have a video here that will help you use the calculator to solve problems from chapters 5 and chapter 6, as well as the end of chapter 4, which was on counting. So let's take a look at the review problems that I gave you, the chapter 5 through 6 reviews. And we started with a permutation problem. Permutation means we're going to look at the number of ways we can arrange values in order. So notice I went to the math probability menu and did 7 NPR2 and got 42. Now there may be a problem where the directions require you to write out the notation. So here I'm showing you on the calculator how to take 7 factorial, which is just 7 times 6 times 5 all the way down to 2 times 1. I enter to get that numerator, and then I press divided by, which takes the previous answer, divided by, and I almost typed 5, but I realized I wanted to divide by the whole product, so I went back and put a parenthesis. 5 times 4 times 3 times 2 times 1, close parenthesis, and again I get the 42. And it should be, at this time, clear that if you cancel the 7 factorial with the 5 factorial, it's simply 7 times 6, which is 42. Now moving to the next problem, which is a combinations problem. The combinations simply look at numbers of groups, in this case groups of 3, choosing from 8 items, and there are 56 groups of size 3 you can choose from 8 items. Given that you don't care what order they're selected in, you simply look at each collection of 3 as a unique group. Now I'm going to do a probability problem involving drawing cards from a deck. In this case you want to find out the probability that you draw 3 cards from the deck and they would all be aces. So you look at how many ways you can draw 3 aces. Well, since there are 4, it's 4C3 divided by how many ways can you draw 3 cards from a deck of 52? That's 52C3, and it gives me this decimal value, which hopefully at this point you recognize as e to the negative 4 means times 10 to the negative 4th power. So you'd have to move that decimal 4 to the left and get a 0.3 zeros and then a 1/8. Now I'm going to do the next problem, which is a calculation of the number of ideal song lists you can get from 9 songs, and you want 4 in your list. So it would be the number of ways you can get your actual desired list, which is 1, divided by the total number of lists you can get in lists implied order, so it's 9P4. Notice I get a rather difficult to read decimal value. It is 1 divided by 3024, and that is exactly the same as 1 divided by 9P4. So I'm showing you various ways to get the same calculation. Now notice the math frac attempts to take that decimal value and change it into a fraction. In this case the calculator failed. Sometimes the calculator does not have the capability to take the decimal number and convert it to a fraction. But if I had something like 0.25 math and then number 1, which is frac, notice it does convert that 0.25 into 1/4. This will help us later see some of the decimal values that we're getting from our calculator and how they can then be translated into a fraction associated with our probability. The next problem is associated with choosing socks from a drawer. You have 8 blue socks, so there are 8C2 or 8 choose 2 number of ways you can get 2 socks from the blue socks. Multiply that by the total number of pairs of brown socks, so it's 4C2 because there are only 4 brown socks. And then I'm going to take that entire value, enter, and get a value for my numerator in my probability. And I'm going to divide that by the total number of pairs that I can choose. And in this case, actually I'm going to choose 4 socks from the total of 12, 2 pairs, and get 12C4 for my denominator. And notice that numerator divided by the denominator gives me a decimal value, which this time when I do the math frac will convert into 56 over 165, which is exactly the fraction representation for my probability. Now moving to problem number 3, which is associated with frequency distributions. In this case it's a discrete distribution. Continuity would imply no gaps in my possible values, and in this case there are definitely gaps in the possible outcomes. In this case the outcomes are 0, 1, 2, 3. And I look at the number of households that have 0, 1, 2, or 3 computers in their home. And recall that the definition of the mean of the distribution is simply the outcome times the corresponding probability, and then taking the sum of all those products. Even though I didn't have to do 0 times 200 over 700, which simply comes out to be 0, I typed it in for your understanding. Notice I get 0.9214. If I take that answer and stow by hitting the stow button in the bottom left-hand corner, that allows me to bring back that number anytime I type the letter M in which I stored the value. Now I can use that M for future calculations. It's a very handy technique to use on the calculator. So I have this value of M stored, and now I'm going to look for the standard deviation of this distribution. And the standard deviation of the distribution is going to be the sum of the differences of the values in the distribution for each corresponding probability minus the average. And now you can see in this case the value, which is 0, minus the average. It would be inconvenient to have to type that number for the average again. So I simply put the letter M by doing alpha M squared, multiply that difference squared by the probability, and that's the first value for my calculation of the standard deviation. Take the second probability, 38 over 700, times the second possible outcome, which is 1, minus the mean, which again, my alpha M makes it much more easy to enter that average. And I get the second product for my calculation of the standard deviation of this discrete distribution. Now I take the third probability, and noting that I actually missed a digit on my previous calculation, at any time you can up arrow or back arrow and go back to the calculation. Second ints, which is above the DEL, allows you to insert digits that you missed, and in that case I missed a 0, so it allowed me to insert that 0. I do the next probability, 95 over 700 times 2, the outcome corresponding to that probability, minus the mean squared. And then finally, we take the probability of a household having 3 computers, 25 over 700, and then multiply that by that outcome 3 minus the mean squared. And if I hit enter, I have what would be the variance for the distribution. But if I now take the square root of the answer, which is second, and then the opposite sign has an ants above it, so I can take the square root of that previous answer. That value, 0.747, is an approximation for my standard deviation for that distribution. So there's a lot of calculation power in this calculator if you learn to use the features, and hopefully this video is helping you better apply those capabilities to your problem solving. Now we're going to take a look at the next problem in the review, and we're looking at the bottom of the first page. The problem discusses a situation where 58% of men consider them basketball fans, and if you select 5 of these randomly and ask them if they're a basketball fan, what is the probability that exactly 4 of those 5 consider themselves a basketball fan? So the formula you've learned from the text was 5 choose 4. Basically you're looking at how many different groups of 4 can you get if you're selecting 5. And then you multiply that by the probability that they actually say yes, 0.58, to the 4th power, because 4 of those individuals are indicating yes, they are fans, and then times 0.42, 1 minus 0.58, and then to the 1st power, because only 1 person would then be saying they're not a basketball fan. And that gives you 0.2376 approximately, which is the probability exactly 4 consider themselves basketball fans. Now you can see we're doing a similar calculation, but this time all 5 consider themselves basketball fans. Now this is a technique that's very helpful. If I take the answer, add it to the previous, so I'll do second enter, get the previous expression, plus second ants, which is again second and then the opposite key, making sure that you don't use the minus key, but you actually hit the ants key. You can see that you get both